Okay, we can get started now. So it's a very special privilege for us this evening to have Shri A.S. Kiran Kumar, the former chair of ISRO, deliver this public lecture. So everybody here knows about ISRO. It's one of the things we are very, very proud of as citizens of this country. We're all familiar with the many, many achievements and, you know, uh, culminating in the recent successful Chandrayaan mission. So, uh, Shri Kiran Kumar did his BSc in Bangalore University in 1971 and then in physics, and then followed it up with an MSc also in Bangalore University. And then he joined IISc for an engineering degree in something called physical engineering, which he told me took people from science backgrounds as well as engineering backgrounds and allowed them to get into new areas. So after his stint, 2-year stint at IISc, he moved to the Space Applications Center in Ahmedabad, where he made a number of very, very important contributions, helping to develop instrumentation systems for many of the missions, the Bhaskara mission, the Mars orbiter, and in Chandrayaan also subsequently, the instruments that were helped in the discovery that there was actually water on the surface of the moon or on the moon. So following his stint at the Space Application Center, where he became the director in 2012, subsequently he became the chair of ISRO, and again, continue to make many important contributions in leading ISRO. So he has numerous honors, which I won't really go through. He was awarded the Padma Shri, the Karnataka Rajyotsava Award, the Distinguished Alumnus of IISc, and also the Legion of Honor, the Chevalier of the Legion of Honor of France, which I read was initially instituted by Napoleon Bonaparte in 1802. So he has a very long. So anyway, so obviously we are very fortunate to have him here, and I don't want to take a whole lot more time. I'm sure you're all very much interested in what he has to say about ISRO and the development of all their programs, all the challenges they have had to face and how they have overcome them. So once again, it's a real privilege to have him here, and he agreed, very readily and very quickly to give this talk, and so thank you.
This is forward. This forward. Okay. Good evening, and thanks to IAC for providing me an opportunity to share with all of you journey of ISRO. And as was pointed out, I joined this organization exactly 50 years back, and today during the course of this talk you will see many 50-year things coming up in this. I joined ISRO in August 22nd, 1975, and very soon I'll be completing 50 years of my association with ISRO. Probably one of the key things we all need to remember is 1957, when the first object was put into space by Russians. India was a fledgling democracy, just 10 years into independence, after many centuries of external subjugation and then a country struggling to provide food, shelter and education to its citizens. Such a country trying to look at what it can do in space and how this whole idea itself evolved is a very important aspect. In fact, how people like Homi Bhabha, Vikram Sarabhai, who actually came back to India as a result of the war itself, and then how their thought processes actually shaped the activity in India, and India started its space program. Unlike any other country, every other country started their space program for military purpose, but it's only India which started the program for non-military applications. And Dr. Sarabhai is considered the founder of Indian space program. He said we should be second to none in the application of advanced technologies to the real problems of man and society. And Professor Satish Dhawan, who is also the director of ISC and he was the chairman of ISRO for a long time, he also said we must utilize the national expertise and capabilities in all our programs. So he was in a way responsible for linking the activities of ISRO to many academic institutions, etc. And of course, Sarabhai said to assure the development, India views science and space technology as a crucial apparatus for its socio-economic development. And another key thing is actually I also had an opportunity later to study what TIFR has brought out on the archives and how the whole activity itself started with Homi Bhabha writing a letter, one of the undersecretaries to the department, the whole activity started. And what Dr. Sarabhai of course said is there are some who question the relevance of space activities in a developing nation. But if we are to play a meaningful role nationally and in the Committee of Nations, we must be second to none. And in fact, this particular church, what you are seeing and the flower as Tumba comes from that. And if you look at India itself as a country, we are 2% of the world's geographical area, 4% of water resources, world's water resources, 17% of world's population. There will be some changes in the numbers, don't go by the exact values, just an indicator. Population by 2075, 1.6 billion. And socio-cultural diversity, connectivity over vast and diverse terrains, adult literacy when the whole activity was starting very low, predominantly rain-fed agriculture, poor predictability of monsoons, uneven erratic distribution of rainfall, declining per capita availability of land and water. So like that many problems are there the country was facing. So in that context, if you look at space and space technology, why and how it could make a difference. Like I pointed out, 1957 is when humanity got, in today's terminology, a disruptive technological capability of going beyond planet Earth, being able to put an object into space and make use of it for various activities. And in 57 this happened and India put its first rocket within the 6th year of that space age, 23rd November 1963 this happened, and Dr. Sarabhai, Homi Bhabha, you can see they were all responsible for initiating the whole activity. And how it all started, actually in India, in the Tumba, we have a place which is a geomagnetic equator, and both Bhabha and Sarabhai were able to convince people across the globe that if you conduct upper atmospheric research at this place, it will be beneficial. So what we are familiar today, you do some activity like doing do-it-yourself kits, get the sounding rockets, brought them here, got it assembled and launched them, so that at that point of time what TIFR was doing with balloons up to 10,000, 20,000 feet, these rockets could go much beyond that and it could collect information about that. So this is how India started its activity at Tumba, and you can see this church what you are seeing here has a very significance. I'll come to that a little later. And starting with sounding rockets in the form of kits, it got assembled and the first launch took place, and then started building the capability step by step. And very first important activity that was done is, again this is called an experiment called SITE, Satellite Instructional Television Experiment. We are completing 50 years of this. In 1975, India conducted the world's largest socio-technological experiment of making use of the satellite technology to reach out to 2,400 villages in the country, 6 remote places. And you can see here in the middle, we are all very familiar today. You have a small quarter-meter antenna on your rooftop, a set-top box, and with that you can see on your TV program. You imagine in 1975, only 4 metros had the privilege of seeing the television. So at that time, the government was demonstrated to the government that if you use the space technology, you can reach out to the entire country both for communication and broadcasting. So what was done is a 10-foot diameter chicken mesh antenna, and with half a rack height of electronic equipment, and a satellite, most advanced technology satellite built by Americans, and it was borrowed because you know geostationary satellite operates over a specific longitude and that covers the local region, and India is exactly opposite to US. So that satellite would not have worked, but the Sarabhai and others convinced Americans the most advanced technology satellite which they were building called ATSF, we borrowed it, moved over India, and for 1 year using this satellite experiments were conducted in 2,400 villages using black and white television sets from ECIL, and you can also imagine at that time power availability equivalent of UPS had to be created, and all that was done, and demonstrating to the country that space technology is the way to go, because otherwise what was the alternative available at that point of time? You have seen microwave towers, every kilometer you have to put a tower, and 3.25 million square kilometers of India, you can imagine how many towers you need and how much of hardware you need, how much of time it would have taken. And also if you tell the powers that be that what you are going to speak can be heard all over the country, I don't think you need any more convincing for get the projects approved at that point of, that's on the lighter side. But the reality is, by conducting this experiment and demonstrating, the government got convinced that if India has to rapidly get information and communication going, this is the way. And after this is, with this, India got the INSAT series of satellite approved, and 80s onwards we started working with our own satellite INSAT series. Another very interesting thing that happened is, see, like I said, at Tumba, in that beach, the fishermen who were there, they had to be convinced that you should allow us to conduct these experiments in this place. For that, Dr. Sarabhai had to take the help of Bishop Peter Bernard Pereira, and using his services, fishermen were convinced that they should allow us to conduct these experiments. And with that, the activity started, and the first assembly took place in that church what you are seeing. But then what was promised was made into reality by 1999. How was it done? By looking at the color of the ocean from an orbiting satellite in 8 different wavelengths. Using that information, you can find out what is the water leaving radiance, and with that water leaving radiance you can see the chlorophyll distribution, and then from the chlorophyll to the food chain of the fish. So you can identify where in the ocean if you go, a fisherman is assured of his fish catch. And this information called prospective fishing zone mapping. This information could be generated and provided to the fishermen. We have almost 11,500 kilometer long coastline, and millions of fishermen depend for their livelihood on this information. And in center in Hyderabad called INCOIS, Indian National Center for Ocean Information System, through them this message was being provided, initially with pagers and then electronic switchboard, etc. But then today what is being done is we have our own Navic constellation, which is actually again a very innovative way of achieving the activity. While America, Russia, Europe and China make use of a constellation of 24 to 32 satellites, India came up with a 7 satellite constellation to provide equivalent of GPS in the Indian subcontinent 1500 kilometer beyond our borders. So today a small battery operated gadget can be fitted in the boat of the fisherman. This gadget finds out its own location, and also a messaging service from the NAVIC satellites allows a mobile in the hands of the fisherman to tell him in a video compass mode where he has to go for fishing. Not only that, it gives him alerts about weather vagaries. If the condition of the sea state is going to be unbearable, or if the winds are going to be heavy, cyclonic, he gets alert in his mother tongue. And many times you also read your neighboring countries capturing the fishermen because they are wading into their waters. Even for that, he is being provided an alert. So now you can see here a person who does not know reading or writing is able to make use of the most advanced technology of a rocket, putting a satellite into orbit and providing all the services. And incidentally, this activity alone saves to the country between 10 to 15,000 crores a year because of the petrol and diesel that is saved and the timing that is saved by the fishermen. Then another very important aspect of your ability to go to space and make observation, you are also familiar, there are different kinds of orbit. One of the orbit is a geostationary orbit. From there you can look at 1/3 of the globe continuously, and by looking at the cloud and cloud images and taking them at regular intervals, you can study and find out what is the wind speed, and also by collecting various parameters you can study on the cyclone and cyclonic patterns. And today it is possible to predict exactly where the cyclone will hit the coastline and time wise, and because of this disaster relief agencies are able to actually evacuate people and save the lives. In the earlier decades, super cyclones used to result in 10,000 to 15,000 or even sometimes 20,000 lives being lost. But today with this satellite based application and the data going into the weather monitoring, only single digit numbers are being counted for loss of life. That too, many times people don't listen irrespective of what kind of warning you give for various reasons of their own. Then apart from that, from space you can do a whole lot of observation, earth observation. That means you can take pictures or images in different wavelengths from optical to infrared to microwave, etc. And then using that you can do agriculture, you can find out what is the crop yield that is going to be ahead of harvesting. There is a center in Delhi called Mahalanobis Crop Forecasting Center, which is doing the job of almost for 21 crop types. They will be able to tell what is the yield that is going to be. Then environment monitoring, land and water resource management. For a long time, the satellite data was also being used for identifying where the borewell has to be drilled, and between 90 to 95% success rate that information was being done. Ocean application, cartography. Cartography is actually for the entire country, not only our own region but neighboring regions also. Digital elevation model using the satellite data has been collected. So similarly, SATCOM, if you take telecommunication, broadcasting, telemedicine, where people from remote places like Andaman Nicobar, patients are linked to the super specialty hospital. Today we are all very familiar with a small your handheld device, you are able to get linkage. Imagine few decades back what would have been happening. So at that time, using the satellite technology, India demonstrated telemedicine and also even tele-education, providing remote classrooms, radio networking, etc. NAVIC application, again here what happens is GPS kind of equivalent thing, which under certain conditions the other countries may or may not allow the capability to be utilized by you. So unless you have your own ability to do those things, you will remain affected by your ability to provide solutions. So NAVIC application, disaster warning and management. Then strategic applications, of course we will touch upon it little later. And for doing that, like I said, 1980s we started with our INSAT-1 series of satellites. Initially, in fact, you can see here the INSAT-1, when it was realized, it was a kind of a design, an equivalent of which did not exist up to that point of time, because we could not afford multiple separate satellite for broadcasting, communication, weather monitoring. So all the things were put in one satellite, and a single satellite was performing. So because of that, complexity was also high, but then it was a cost effective manner. So we visualized such a system, and then INSAT-2 onwards it's all indigenously realized, and today you have a number of satellites providing this capability. Similarly, in terms of navigation, like I said, while these other countries were looking at a bigger constellation, we adopted for India and surrounding Indian boundaries the ability to provide, again because of a cost effective alternative to address the problems we are facing. In fact, this NAVIC based service, as well as what is called as a GPS based support system, all aircraft which are registered in India beyond 2019 January are required to carry this Gagan enabled service receivers to help both en route planning as well as precision landing. And this also has come in a handy because India upgraded a large number of airports, and in all airports if you had to build in the instrument landing system, the cost would have been much more, but this satellite based solution provides an effective alternative. So this of course in this system we were making use of the GPS, but with a number of ground receive station corrections data is provided for the receiver, which will make what is called safety of life. Otherwise today if you are using your GPS signal as it is not 100% certain it gives you correct result, but this service, Gagan service, because safety of life is involved, it provides. So India started providing some special satellite instruments on the geo satellites to enable this, and 2015 onwards this is operational. Now for taking images of the earth, starting in the Bhaskara, the first image that was generated was a 300 kilometer by 300 kilometer image in 2 wavelengths, and with that, with 1 kilometer resolution. Gradually we have built up a capability, and today we have 30 centimeter resolution capability imaging, which can be done from various platforms, LEO, GEO, and even platforms which are going much farther than that. Similarly, in terms of meteorological requirements, to enable providing various information which will go into the weather monitoring, many times you may also wonder, between June to September India is fully cloudy. So what can you see from space? Are you seeing only clouds? But then, like, we can see through through glass in a transparent manner. Microwave can see through clouds and you can collect data. So there are wavelengths in electromagnetic radiation. So we have built instruments using microwave region also to enable, and you can also measure various ocean parameters. What is the sea surface wind, sea surface temperature? You can easily imagine, before the space technology became available, human ability to observe was only limited to land and where they were actually physically present. But 3/4 of the globe is not covered with any observation. So when the satellite started becoming available, humans could get observations over the ocean, and this data went into the numerical models, and that's how weather prediction started improving. And again, when it improved significantly in the temperate zone, in the tropical zone still the problem was severe, because both the predictability and the model variability of the parameters in that tropical zone is much more, while in temperate zone you could get very accurate predictions. Over tropical zones it was still difficult, but then progressively things are improving. And similarly, hyperspectral imaging, like we can, most of the time your whatever mobile is there is giving you in 3 colors, but if you are able to make observation in a large number of wavelengths, then your ability to retrieve information significantly increases, and India also is able to generate a number of instruments. Microwave is another thing which I was talking to you about. While when we take a picture from a camera or a mobile, if no light is there, you use a flash in that. So like that, in microwave region, by carrying your own source of illumination, you can make observation at any time of the day, or by illuminating an object and getting the scattered signal from that, you can make measurement. So using this, we are able to generate sea surface temperature, sea surface winds, and then a whole lot of parameters. And again, during cloudy periods, etc., the data can be generated. So what India has done is, it has built a number of satellites with different kinds of instruments, and then a digital elevation model using our own satellite data, and optical, microwave, hyperspectral, multi-temporal, and a navigation enabled positioning. So with all this data going into the models, a suite of applications which will help in addressing socio-economic, security, sustainable development, disaster risk reduction, governance. In all these areas, it was possible to carry out significant activities. So one of the things that was done during the period in 2015 was, see, it is one thing to build a technological capability and collect information, but it is a whole lot of different domain to convince the persons who are using it and tell them, using this technology, what you are doing can be done better or differently. So normally you will see the human tendency, if somebody comes to you and tells what you are doing can be done differently, first reaction will be, who are you to tell me, I know my job better. So obviously it took a lot of time for convincing. I'll show you another slide how things happen. But here, if the people who are actually making use of the thing for governance and for operation, if they make it a point, then they can force application. So in this particular event, all the secretaries of government, central and state governments were brought together over a 2-day program. What information from space technology derived data can be used by the various departments for their application. That was showcased, and the Honorable Prime Minister at that time spoke extempore for 45 minutes, telling the secretaries how the data can be used for various applications. That was because he was using it extensively in Gujarat, both in terms of remote sensing, communication and broadcasting. Many of the things would be, suppose you have to actually build a new hospital or a new school, the way it was being done is not on the advice or the, you can say, recommendation of a MLA or a influential person, but it is on the basis of how much of walking the students have to do to reach their school, and if you put a new school, how can you reduce that? Similarly in the hospital, a whole lot of things like that. So because of that, things started changing. Then institutionalization, like I said, we started the space activity way back in the 70s and then 80s onwards. With each new technological capability that is being done, you have to go and convince the department that you can make use of it and improve. So you can see Ministry of Environmental Forestry, they started using it for biennial state of forest report from 87 onwards. Ministry of Earth Sciences for potential fishing zone from 99 onwards. Similarly, crop forecasting, they started using in 2012, and then civil aviation 2003. So like this, different set of people, we had a mechanism called NNRMS, or National Natural Resource Management System, where the information was being provided and then programs were done. And in addition to that, you are not only doing all activities yourself, but you are also doing collaborative activity with other nations. An instrument called a Megatropics, or a satellite called Megatropics, which carried imaging radiometer, which provided humidity profiler as well as radiation scanner, etc. And this satellite was launched by us. And similarly, for measuring the sea surface height, the Saral instrument was used. And India also provided, it's true to its traditional belief that the knowledge and the skill you acquire should be for the benefit of the community and society. So India offered its ability to provide to many of these countries, neighboring countries, free transponders for various activities. And in fact, on this particular occasion, I remember when this launch took place, all the heads of states were there on the video mode immediately after the launch. And Afghan president, he made a statement in that. See, we are used to people making promises of giving something, but here I am seeing for the first time a promise being made is fulfilled in real quick time. So you can see the kind of activities that went on at that point of time. Similarly, of course, apart from the various activities, space science is also an important aspect. Right from the early days, sounding rockets which were carrying in fact some sodium vapors, and they were dispersed in the upper atmosphere, and then Aryabhata carried certain instruments, and then progressively it went Chandrayaan 1 2008 Mars orbiter mission. We will see some details in subsequent slides, and then up to Exposat in 2024. It is a continuous process. While you are building the capability of using space for various activities, this is how space science program went on. And of course, Chandrayaan 1 mission itself, if you look at, see, many times when you look at, you want to build technological capability, you are very familiar that things keep changing at such a pace. Even if you want to stay where you are told you have to start running. So in the same way, if you do not challenge the people who are working in this area to solve bigger problems or more complex problems, their ability to find solutions remain restricted. So while we had built satellites which could go up to 36,000 kilometer, here to go to moon 3,84,000 kilometer, you have to build systems which were more capable, and also you are going to get into an orbit around another celestial body. The environmental conditions are different, and with this launch vehicle that we had, this whole program was envisioned. And with this, in 2008 when this activity was done, you can imagine man had already landed on moon and a large number of probes had touched the surface of the moon. But still, when this particular satellite gets the credit for discovering the presence of water molecule and also identifying the process of water molecule formation, what it also shows is, in science and technology area, it is never too late. You can always do something which others have not done, and this was a one such demonstration. And also I will touch upon this aspect a little later, how this particular thing was conceived. We had a launch vehicle which had a limited capacity to put an object with a certain velocity. So though this concept of using progressively increasing elliptical orbits was there, we were the first to adopt this for usage in 2008 and then reach moon. And then of course Mars, when it was done, again it was a very novel way of doing the things. And then just to recap the kind of complexity this mission had, on the 5th of November when the satellite was launched from Sriharikota, the task cut out for the satellite was travel a distance of 60 crore kilometers over 10 months, and at the end of that period, on September 24 morning 7:30 a.m. to the second, you imagine a cube of 50 kilometers in space. If this satellite had not been inside that cube at to that second, it would not have been possible for us to achieve orbit around the Mars. And also, what could have caused deviation to that? Even sunlight falling on any surface produces some very small force, and it is even less than you hold a paper and blow, then it's much smaller than that. But even such a force can deviate the trajectory of the satellite when it is traveling over that period and take it tens of thousands of kilometers away. So you have to make sure that you are constantly in touch with the satellite, you are able to correct it, you are able to know. And also here, even at the speed of light, it takes almost 13 to 14 minutes to reach the satellite. So if you give a command from ground, it takes almost 13 to 14 minutes to reach there and another 14 minutes for it to come back. So almost half an hour. Many times when you turn on your laptop or a computer, it takes few hundred milliseconds extra. Then you start feeling fidgety. My system is very slow, I want to get a faster system. So you can imagine the plight of people sitting there operating and conducting this. But also another thing is you can see school students getting excited, and this is in 2014, much before our 2019 and 23 event. But then again, this particular event made the world look at India, because they were all surprised how it happened. And because India is the first country in its maiden attempt to achieve this particular thing. So here again we made use of the similar concept of using progressively increasing elliptical orbits. Every time you come to perigee, you add a small acceleration or a velocity to the component, so it progressively increases. So within the limitations of what you have, you are able to achieve these activities. And again, one of the things that had to be done is an engine which had been shut down for 9 months, after that you had to revive and restart it. So you can imagine many times whatever system is not operated for a long time, what will happen to that. So there is a whole lot of challenges that. And another thing is of course 32-meter antenna, which was also built here in Bangalore, with all indigenously built, which was used for this activity. These are just some of the images, including the moon, Deimos and Phobos, moon of Mars. And then we also had a mission, AstroSat mission, where ISRO in a way enabled many academic institutions in the country. And this particular telescope, the beauty is, in a specific wavelength region, it has the highest angular resolution and higher sensitivity than any other satellite operating even today. So because of this, there is a lot of virgin data available to Indian researchers, and they have found many interesting things and made an impact globally. Then of course in Chandrayaan 1 we had a moon impact probe which descended from an orbiter and touched down the surface of the moon in an uncontrolled manner. In Chandrayaan 2 our objective was to make an lander and rover touch in a controlled manner, and then with that do the operation. But of course what happened in Chandrayaan 2 was we came very close to touchdown, but certain limitations did not allow the soft touchdown, and we crash landed on the moon surface. But then whatever was learned from this enabled us to successfully do in 23 Chandrayaan 3. Of course this just shows you the lunar hydration, detection of See what was found in Chandrayaan 1, we built instruments in Chandrayaan 2 which were able to provide a larger wavelength coverage. In Chandrayaan 1 we had a spectrometer which was going up to 2.9 micron, whereas here it was going up to 5 micron, and here we had dual frequency synthetic aperture radar, whereas in Chandrayaan 1 we had a single frequency radar. So like that lot of improvements were done in Chandrayaan 2, and Chandrayaan 2 the orbiter is even now providing lot of interesting information, and not only it is providing data for us, I will touch upon that little later, how Chandrayaan 2 helped us really succeed in Chandrayaan 3. You can see here the one of the satellite images which shows small boulders and craters with great detail. So Chandrayaan 3, of course, in Chandrayaan 2 the real issue was, for the first time we were building a engine. That engine required throttling. Up to that point of time, whatever rocket engines that were built, the way they used to operate is, once you start firing, it keeps delivering fixed thrust till the fuel is exhausted. But then when you want to come down and touch on the surface of a celestial object, as you keep coming closer and closer to the surface, you should be able to change your deceleration or acceleration, because otherwise you cannot do soft touchdown. That means throttling requirement was there for the engine. So we were building for the first time throttleable engines, like you can accelerate, decelerate. So in those engines we had certain mismatches with respect to each other, and because of that final very few 100 meters we got into problem. But then in Chandrayaan 3, how did we manage to solve all those problems? First thing is, you can imagine if you want to go and touch down anywhere, you need to know that place very accurately. That means what is the area, how much of craters are there, what is the size of the crater, what boulders are there. For Chandrayaan 2, we had to depend on this data from others, because till that time we had no data from our own orbiter. So whatever data was available, with that we could identify only a 500 meter by 500 meter area where we could have touched down. But in Chandrayaan 3 time frame, we completely mapped the entire area, and we were able to identify a region which was 2 kilometers by 4 kilometers wide, and within that any 100 meter you can touch down safely. That means one of the problems of your activity where you are going to touch down, you have a larger error margin. Similarly, from where you start descending, that also requires accurate information. And more than this, we also built the whole mission in such a way that while you are in orbit, you test all the features, even the engines, throttling of the engines, they were all tested. So that's how in Chandrayaan 3 everything went with precision, and we were able to successfully achieve the particular touchdown. See, here is where what I wanted to show you. See, you are starting from a height of about 31 kilometers, and almost about 745 kilometers you are covering, and during this entire period you are maneuvering your object with the knowledge of various sensors and then control system. So if any error happens in the whole process, where you come down, the error margin on that, if it is more, then you have more robust system. And in addition to that, when you reach that place, you are hovering, you take a picture of that, compare it with a picture which you had already taken earlier, and with that you maneuver and touch down. So in this time we had everything generated by our own source, and we could successfully do the whole operation here. And then this is of course just to show you when the rover moved on the surface more than 100 meters, it moved there. And then few more experiments we were able to do, because we still had enough fuel available, because everything went as per our original plan. So lot of margin of fuel which was there. So conducted an experiment where in the next time when we want to fly back, you have to take off from there. So we conducted an hop experiment using the fuel that was available. Then another thing that was also done is, instead of leaving the object orbiting the moon, can you bring it out of the moon orbit so that you don't leave it as a debris. So that was also done using the propulsion module of Chandrayaan 3. And there of course many interesting results came from the rover which went around. First characterization of a near surface lunar plasma, and also APXS. Actually a lot of papers have come out in Nature, etc., showcasing, because we were the first to reach this region, you are able to determine first ever temperature profiling of lunar regolith up to 10 centimeter depth. One of the key things it has shown is the ability of this regolith material for acting as a thermal shunt, so that thermal shielding. So you can use this material later when you are putting habitat, and maybe using this itself you can protect what is there inside. And then this data is also available in our website, and it can be used. That's one. Then similarly, just after this we also did Aditya experiments. Currently it is providing data, and many of you are very familiar. Total solar eclipse, whenever it happens, earlier people used to spend lot of time and effort for conducting an experiment a few minutes at the location where total solar eclipse is visible. Whereas in this solar coronagraph, you can do that observation 24/7 by reaching a point which is called a Lagrange point, where one side you can always all the time look at sun, and the other side you look at earth, so that you can transmit the data you have collected 1.5 million kilometers from earth. And this was also successfully achieved, and then today we are continuing to get data from this. There are a number of scientific payloads which are providing information in this. Okay. In addition to that, see, we are also trying to provide how to make use of whatever resources and capability you have and learn something ahead. For example, space station is one of the things that was being looked at, but then much before that we started thinking about how can we make use of our spent fourth stage, which will be orbiting Earth maybe for few months. Can we make use of it and provide opportunity to conduct experiments? So that's how this concept came. So starting from C-38 itself, we started looking at how we can make use of the spent stage of the the rocket, fourth stage rocket, and provide many opportunities. Microgravity and experiment, rendezvous experiment, and also I'll show you one of the biological experiments that were conducted, robot arm, etc. CROPS was flown in the last mission, which was in December of last year, and then it was in a 350 kilometer orbit. CROPS payload was, I'll show you the outcome of that. You will see this is a equipment which carried the chickpea, and then water is sprayed. After that slowly it blooms and you see the life coming out of the seed there. This of course just time lapse photography taken, and this entire thing is encased in a container with its own power source, etc. So this is one of the experiments that was conducted on the poem which I said, which was orbiting Earth. Okay. Now for doing all this over a period of time, starting from 60s, there are about 232 total mission, 63 PSLV launches, GSLV, LVM3, SSLV. These satellites were done, and about 131 satellites of different categories, science, not only our own satellites, but we also put 433 satellites of 34 countries, and then about 18 student satellites, re-entry missions, and then crew module re-entry activity. These are all done. And of course, there, if you take a launch vehicle, it has got a huge number of different systems. In fact, in the avionics, we actually realized using our SCL 180 nanometer foundry processor chips which we are flying in the control system of the rocket, and we have also flown from SCL foundry like ocean color monitor, what I talked about. The latest version of the ocean color monitor carries detectors which we realized in SCL foundry. And then starting from 63 progressively it is going, and now today we are trying to look at how to increase the capacity, and while the increased capacity is happening, we also need to provide cost effective launches. SSLV, some of you would have seen already, technology transfer is identified. One of the public sector undertaking is taking this technology and is going to produce for commercially. And starting from 62, if you see progressively how it has moved, the dedication of TULS in 1968, Aryabhatta got launched in 75, and then SLV3. So progressively up to SpadeX. In fact, SpadeX is another very interesting experiment which happened. Here again, we are trying to look at all the time within the limitations of the capabilities that you have today, how can you learn one more step and make it effective. So SpadeX is an experiment where two microsatellites orbiting in space can actually come closer to each other, dock, undock. So this kind of activity we demonstrated this year by using two microsatellites that will help us in addressing the problems which we are going to face subsequently for manned mission, docking, and even subsequent Chandrayaan missions, etc., where sample return is going to happen. See, while all this was happening, the world is not remaining same. World is moving ahead while we are building this capability. So today, if India, starting from a lower position in economic arena, it has become the fourth largest economy, and if it has to reach what it is aspiring to by the time we reach 100 years of independence, you cannot but generate capabilities which is commensurate with top line. That means if you have to be contemporary and you have to be among the equals, you have to have a capability. So today India is among the 5th, 6th in various launch vehicles, satellite applications, etc. But if you do not build a human capability, the ability to carry humans to space and do the activity, you will fall behind. So India decided by the time we 75th year of independence, we should have put humans around orbit and brought them back. But then COVID had other ideas, and then a whole lot of things got delayed. But in less than 2 years from now, you will see Indian astronaut going to space and coming back. And for this, one other thing that required to be done is the launch vehicle has to be converted into what is called as a human rated vehicle. Because when you are putting only machines in these things, the kind of risk you can take is different from when humans are there. So human rating becomes very essential, and that is a continuous process. So it's going on, and we will see before the end of this year uncrewed missions will happen, and next year we will also have 2 of the uncrewed mission, and following the successful uncrewed mission you will have the actual manned mission going in. And this activity brings in a whole lot of new things, from because life beyond planet Earth is there, the total number of areas in which one has to work becomes very significant, and humanoid robotic systems, and then environmental control and life support system, all of them become important, and it is going. So similarly, like I said, the India decided that it will do its manned mission, and then now even before that is completed, it has already decided we will have a space station by 2035 and then landing on moon by 2040. Why all this is happening? If you also see, if India has to improve on its economy, space economy is a $1 trillion economy very soon, and if India does not participate significantly in this economy, it will get left behind, and only government cannot do the activity. A whole lot of people in the country have to work for that. That's how India started changing its policy. It has started bringing in entities like Indian National Space Promotion and Authorization Center, and also New Space India Limited, where the company is going to own many of the assets and provide as a service, and then InSpace is an entity which is going to support private sector participation in space and enable them to do a whole lot of activity. Already significant movement is happening in this area. There are some companies which are taking technology transfer. There are private companies which are actually putting their first object into the orbit, and there is a company which is producing engines, 3D printed engines, much ahead of even ISRO in making such things. If you look at overall space ecosystem, there are 500 plus MSMEs, 50 large companies are there, 200 plus startups have already come up, and then academia, etc. If you see, there are significant increase in the engagement that's happening. So this is the policy which I talked about, which change, that share products, process technologies and best practices with NGEs, provide the resources available for testing, etc. And then there are a whole lot of activities which are being conducted to enable this to happen in the private sector. Then these are the 3 main elements in that. One is the what will be the ISRO activities, what will be the NSIL activities, and what will be the InSpace activity. InSpace will also act as a regulator, authorizing agency, handholding of private players, and then single window, and identify and authorize use of ISRO facilities, launch authorizing, like this. So the things are changing and the government is going ahead. And academic interface also, if you see, progressively 6 regional academic centers are there for spaces, then space technology incubation centers are there, space technology cells are there, sponsored research activity. In all of this, actually a lot of work is in progress to change from the previous way where it was only the ISRO that was doing all the activities. Now a whole lot of people in the country are expected to do. Now what is going to be subsequently how things are going to happen. This is one slide which shows that future is the human space flight activity, and then moon habitat by 2040, like I said, whole lot of experimental thing. So you can see we are at 2026, you will have the human space flight capability through H1 mission, then space flight, the first module to Bharatiya Antariksh Station, and then by 2035 have your own space station, by 2040 landing on the moon. And towards this, in all the different areas, a lot of things are being visualized, and you need technological development in very many areas which needs to be actually addressed. This is where there is a challenge and there is an opportunity. Challenge to visualize what can be done even without being told by the organization. Lot of scientists and researchers can think on their own because basic targets are there. If you are going to land on moon by 2040, obviously the activity is also not going to end there. Moon is going to be looked at as a place for observatory or a stopover for future launches to other space station. It is like an in-between station, and then manufacturing things on that place. A whole lot of things are possible. So impact of space program, there was one study which was done. Of course, my own assessment is a very conservative estimate which said for every rupee spent, 2.5 rupees is the gain. But anyway, it's a very probably conservative estimation in my opinion, but these kinds of activities are also going on in that. Okay, that's the basic information. Now I'll just touch upon few of the aspects in terms of technology and in terms of the approaches of ISRO. See, one of the things Sarabhai's vision, as you saw, was leapfrog into the future through adoption of appropriate technologies. How it made a difference. First example was SITE itself. SITE, where we borrowed the most advanced technology component from an advanced country, demonstrated a solution relevant for our country. Not only that, but it also showed for developing countries how it could make a difference. And even in conceiving that satellite, there was a novelty. 3-in-1 was adopted. Such a thing did not exist up to that point of time. Then between 95 and 99, India had in the civilian domain highest resolution imaging system. As a result of that, almost 18 ground stations across the globe was receiving this data, and even US created its complete US map, cloud-free images using this data. Mars orbiter mission, first country in its maiden attempt to achieve the success. Astrosat, like I pointed out, it even today has in a specific wavelength what others have not done. 104 satellites was launched in one go. So here again, it is not so much how many satellites got launched, but it is a ability to show while you are doing your activity, you can do many other things parallelly. The prime satellite in this launch was a Cartosat high resolution satellite which was being done. When you had enough extra resources on the satellite, how can we make use of it for getting some remuneration or returns? So when we started this mission, only 68 satellites were there, but within a matter of few months, the ISRO was ready to change its plan and do all the mission studies required for accommodating 104. It's only when you are very agile you can do such things, because normally in space launches, unless years in advance you have to fix up, months in advance you have to fix everything and go ahead. But this was possible only because of that agility, etc. Now leapfrogging itself as a concept, if you see what it means, sorry. Suppose you want to do a high jump. If you do not have even enough space for building the momentum by running, what do you do? So if you do not have the resources for doing what you want to do, conserve whatever resources you have and do a jump like a frog and then reach the height. That's the concept, and this is how many things were done by India, adopting whatever technology that was accessible to us, we made use of. Like I said, satellite from America, and similarly when Europeans were launching their first rocket, Ariane, they said we will give you an opportunity. If you want to put a satellite, you can put. Obviously in the first it is not certain whether the launch will be successful or not, but then that opportunity was picked up. We built Ariane passenger payload experiment and learned the tricks of how to build a geostationary 3-axis stabilized satellite. Similarly, when Russians offered we will put a couple of satellites for you, we made use of it and built. That means try to make use of whatever technology that is accessible to you. Learn. Sounding rockets, I already told you, started as a kit and went ahead. So similarly, use of enabling technology, and then innovate in the innovative concept using the existing technology for addressing the problem which you are facing. That is a key. In fact, this is a very interesting say from Dr. Sarabhai. The important ingredient for satisfactory meeting the challenge of the changing environment is not experience, but an ability to learn. Actually, when he was given the task of running Ahmedabad Textile Industrial Research Institute, when he started his career initial days, he put an advertisement in the paper. It said, people with experience need not apply. See, it looks so counterintuitive, but then you see the problem of today also. What it is trying to tell is, there are certain kinds of activities where experience is important, but the same experience can become a limitation if you want to try and solve new problems, and if you want to look at the entire thing in a fresh perspective. So in that context today, we are all very familiar when it says the things are changing at such rapid pace that if you want to adapt yourself, what you have learned you have to unlearn. So that is the key there. Experience is less relevant than knowledge and the ability to learn and innovate. And then again, another important thing is, technology is not an objective to be aimed at, but a tool to be used for the benefit of common man. In fact, these are the basic you can say premises on which ISRO has built up its whole activity and has been able to successfully reach where it has reached today. And then what is in store ahead is a whole lot of diverse thing. World is changing at such a rapid pace. You are seeing globally how things are changing, and then the only way we can make sure that we reach where we want to reach is being focused, do teamwork, and then respect each other and work together. If we are able to do that, I don't think anybody will be able to stop where India wants to go. Thank you very much.
Thank you for such a wonderful and inspiring talk, and I'm sure you will be willing to take questions. So this is a very special and rare opportunity for many of us. So please take advantage of it.
गुड इवनिंग सर, दिस इज निशांत शर्मा. सर, इसरो को एस्टेब्लिश्ड हुए 55 ईयर्स हो गए हैं, बट अभी तक कोई भी एस्ट्रोबायोलॉजी इंस्टीट्यूट नहीं है. वाई? सर, वी आर द फर्स्ट जिसने सबको बताया दुनिया को कि मून पे वाटर है. सो वाई अभी तक नहीं है?
See, one of the key things you need to appreciate is, like I was telling you earlier also, for any activity you do, you also need resources. And as you keep building your ability to do things, you will move ahead. That is one. Other thing is that enough champions are needed to drive something. So maybe you can become a champion and drive it.
Sir, the thing is opportunity.
No, opportunity is always available. You have to create.
Yeah.
Anyway, it's a difficult task. I'm not saying that what you are saying is not correct or anything like that. But then, in spite of the limit, like you said, for example, when Dr. Baba and Sarabhai, when they were looking at that time, India was a fledgling democracy struggling. Who would listen to them to say that you have to go to space and do some activity? finally, whatever way they managed, isn't it? That means if there is a desire and perseverance, things will happen.
Okay.
Yeah.
It's not easy, but definitely possible.
Sir, I am a bio person.
No,
How
I
can
think
I apply?
I think
Yeah.
let's move on. You can talk to him later. Yes. A little bit of nepotism here, but
So you said that the satellites can actually look at the Earth from above, right? So my question is, can they capture, like in a video, very slow processes like erosion?
Yeah, correct. See, probably you are also familiar with what is called time-lapse photography. That means if you take changes with long gap, that is one. Other thing is you should be capable of making observation continuously. If you are able to keep observing continuously, then you can make observation at whatever interval you decide. And today also, for example, last 30 to 40 years of data collected over Earth is being used for climate change studies. But when you want to understand the climate change studies, you are making observation of certain specific regions for the parameter you are interested at regular intervals, and then quantitatively analyze the values and see how changes are taking place. So it is possible to do, and it is being done.
Sir, just a layman's doubt. So we are sending a lot of satellites, and after a specific period, these become useless. So is there any mission to bring these satellites back to Earth?
Yeah, correct. See, here is again one of the key things we need to appreciate is what is the first desire the human being has. If he wants to do something, he will do it irrespective of anything. He is not worried at that point of time what is the cost of doing that, what are the implications. So same way, humans, when they wanted to go to space by putting an object, initially the whole objective is how can I do that. Then you start worrying about, okay, can I do it cost effectively? Am I creating problem? Today what you are saying, Elon Musk is looking at providing 42,000 satellite constellation for enabling internet access to anybody on Earth, anywhere on Earth. That means a huge number of satellites will be there. So today also, starting from early days, if you see, there are a huge number of things. But now when it becomes a problem, there is a space traffic management, and also thoughts of how can we design features into the satellite such that they do not remain there. For example, geostationary orbits was one of the important things where it was being allocated by ITO to the nations. So whenever a functionality was completed, then that satellite was being pushed into an orbit called graveyard orbit. That means it no longer prevents other satellites from occupying that. So today lower Earth orbits are becoming problems like that. Space debris is becoming an issue. But then there are also now companies which are building capabilities, waste to wealth or scavenging, and also refueling. So they are setting up stations where they can come to your satellite, refuel and make it active, repair them. So these are all natural activities in any enterprise, human enterprise. First thing is, I want to achieve something, I will do it at any cost. Afterwards, I will start worrying about its negative impacts, and then economics will drive and start solving that. Today, all that is going on. Already companies are becoming viable for doing such activities.
One of the, I thought in the world setting, at least my impression was that one of the advantages of the Indian program was that costs per launch were much lower than competing international launches. But one of the things, at least one hears in the popular media, is that with the use of these reusable launchers that you mentioned some time back, the costs have come down even more than the Indian cost. So is this a challenge for our vision looking forward, and what are we doing to address this and build this kind of technology here?
Yeah, we are also now working on, see, current launch vehicles what we have, even if we bring back the first stage, etc., it will be, what will come back is only a casing. So if you have liquid engines which are there, if you bring back them, then you can refuel with the and use it again. So like you saw already, we have done couple of experiments of doing reusable launch vehicles. So this is a activity in progress, but then for doing all this you also need enough resources. Today, no matter what, just to give you an idea, the total amount of money India has spent on space program, even after adjusting for the value of money, all that if you put together, it is less than a fraction of 1 year's budget of any of these advanced countries. So with that kind of resources, can you compete with what others have done? That is a thought process you have to keep in mind. But anyway, notwithstanding that, unless you build such capability, you are going to be obsolete. So obviously, you have to find cost effective ways of building reusable launch vehicles which will bring down the cost in comparison with others. That is one part. Other part is competence, geopolitical things, how it changes, you never know. So if you have to depend only on others for doing what you want to do, you can also be in problem. So you should be prepared for both.
Are there any concrete targets that you mentioned, for instance, the space station by 2035 and
Can we
Yeah.
restrict to single questions?
Yeah, that is the target. No, 2035 is the space station. So country has to work towards making it happen.
Hi. First of all, thank you so much for a comprehensive overview of Indian space program since independence. I really enjoyed your talk. I wanted to ask, so these are the missions you mentioned, but are there some near future programs for more exploration of fundamental sciences like astrosat kind of missions? I've been hearing a little bit about Daksha or some other things, but is there any like concrete programs about in those directions?
Currently, in terms of space science activity, if you see, one is follow-on lunar missions. There is a sample return mission that is there, and there is a mission which, along with JAXA, where we are building a huge lander there. And JAXA is going to carry it and land on that. And then coming to astrosat follow-on, still it is in the works. There is nothing concrete which has been approved, but at the same time, many other missions, today approved missions, if you look at, it is Chandrayaan 4, which is the sample return, 5, which is the JAXA mission. We have a Venus mission which is approved, and then Mars 2 mission which is approved. But astrosat follow-on and equivalent, there are certain smaller ones which are there, but exact ones is still not framed, but it's in the pipeline.
Yeah, that's what I meant. These are specific missions like for moon or for sun, but this astrosat is more general towards exploration of the unknown universe.
Yeah, one of the things you also need to appreciate is what the government is trying to tell us is, unless there is enough force coming up from the operating system, we will not fund it. So the task, anyway, it's a task. Earlier when, for example, only ISRO was looking at what is happening in space, certain things were driven, but that time the problem for the scientific community was, we are not certain what is going to happen, but now you can see up to 2040 lot of things are defined. But then how to, you can say, modify our plans to meet what we want, make it happen in these missions, should be the way we should look at. It is not necessary that you should look at exclusive separate mission. There will be many opportunities for scientific payloads which can be carried on our space stations or on our missions which are going to moon, etc. Whether that can be accommodated. But notwithstanding that, if enough drive and force is there, demand is there, things will happen. Because India is anyway growing now economically, etc.
Makes sense. Thank you so much.
Sir, I would like to ask, we went to Mars, we went to Moon, and the Chandrayaan 2 mission was a lander plus there's a docking system. So instead of sending the satellite in one go, the SPADX mission where we learned how to dock, I think it should have came very earlier in the stages of ISRO, where you could just send the instrumentation satellite first, and the engine and the fuel the next, dock it together, then you have
even for sending the first one, what you are telling, you still need some engine and this thing, no?
But So instead of suppose I want to go to Mars, I don't want to send enough fuel. Just I want to just send it to
That's
low
why I
Earth
understand
orbit.
your question, but what I am saying is whatever you want to send still requires some propulsion system to reach there. Without propulsion system, whatever you want to send will not go, no?
But you can't refuel with docking. So I think
That is much later, isn't it? First thing is you need some propulsion system to take you there. It is like what you are telling is, let me carry a scooter to some place and fuel it there. But to take it there, I have to do some activity.
it's like I take a scooter to there. and
But how
attack-
do you take, whatever you are using for taking is already doing a job, no? In space, for doing that you need a propulsion system.
Just 1 second. There's a question.
Good evening, sir. I thought that session was out of this world. So I just had a very simple question. Could you just walk me through a day in your life? What does your typical day at ISRO look like? I'm quite curious. Thank you.
No, typical day will look, it depends on when I was starting my career or when I ended my career. In the initial period, for example, there have been periods where I have worked 72 hours non-stop, not going home from office. So if that tells you anything, that is one. But there are other times where we have not gone to office for 72 hours.
Sir, you have told that we have launched many satellites which are giving information to the agriculture sectors, that when to sow and what crop yield we will get, those things. Are we giving any information through ISRO or through the government to the farmers?
Yeah, see, again you need to appreciate ISRO's task is to generate information, and then the actual task of reaching it happens to be the various other ministries, etc. But notwithstanding that, even to convince that ministry this is the way to do, we had to do that job for a long time. So we did do it, and we did go to the people and then even farmers. There are a lot of activities which have been going on,
Yes,
and even today it happens. But then primary responsibility, if you take, IMD has the responsibility for providing whatever cyclone information, prediction, and there are also methods by which through mobiles information is being disseminated to farmers, both with respect to rain, soil
Yes, sir.
properties. There is a whole lot of activities which goes on, but then ISRO's task is to demonstrate.
If every
Provide-
farmer receives that information,
Yeah,
then
yeah.
we can have more
No, he is
crops
receiving,
also,
that's what I
sir,
am telling.
that's why.
It's not that he is
So
not,
it's-
even today he is receiving.
Okay, sir.
Okay,
Thank
so
you.
so
Thank you,
so we'll take 3 questions, one from the back, one from here, one from there, and then we'll conclude. And I'm sure you
Good
can
evening,
talk to-
sir. Excuse me.
Yeah.
This is Tendril. My question is like pretty basic. So, have you ever thought of addressing this common question, which probably everyone might have? Are there life beyond Earth, not the alienated one, but the typical through astrobiological lenses? Like it can be any form, ranging from simple unicellular prokaryotes to like at least a cell, or to some complex entity.
Yeah, first answer will be, if I don't know what I am looking for, how will I tell it is there or not? See, today one of the questions is, what all constitutes life itself is still a question mark. No? So, at least what we can say is what we know today, we have not found outside with in a credible manner. Maybe it is there, but in a credible proof of such a thing exists beyond has not yet happened. But if you are thinking of life forms which we are not able to define today, then maybe it's here also, aliens.
Good evening, sir. My name is Ayushman. During your talk, you mentioned that a lot of the people will have to help India achieve what it has to eventually. So, in the spirit of initiative, I would like to ask you this question: what are some of the I'm currently an undergraduate student. So, what are some of the problems that ISRO faces currently, which will have marketable solutions, which can be built upon by individuals here and over the country of my age? We can develop technologies eventually. And a small follow-up question is, this is very small, sorry. I remember the news that ISRO tested a cryogenic engine in February this year, and recently something about liquid engines came up. So how far along is that?
See, if you look at cryogenic engine itself, we are using cryogenic engines in our launch vehicles, GSLV, geostationary satellite launch vehicles. So now we are looking at using, actually if you would look at in the long term, can you build a propellant-less propulsion system? That means, for example, when you are in the atmosphere, you are picking up oxygen en route and then using it for your activities. But then once you go into space, even that is not possible. So can you pick up material en route, interstellar, etc., and use that for propelling yourself? If you can come up with some such solutions, it can be fantastic thing. But then whether commercially it will give you returns, I am not sure immediately you will find, because the people who can use that will be very limited. But apart from that, your real question is, what is it that can give you commercial returns for which you can act? I am sure if the answers were known like that, a lot of people would have done it already. So it is for you to find out such a thing, and it is your another thing also I would like to tell. Anything that a human being has done so far, the concept of that exists in nature. It is those who are able to visualize that ahead of others who have made a difference and who have gone ahead and achieved success. So if your ability to look into nature and then find a concept which you can make it workable for you, you would achieve your target. Otherwise, I cannot give you a specific example where I can tell you, you do this, you will become a billionaire.
Yeah, towards the end of your presentation, you gave us an entire roadmap until 2050 as to what ISRO is going to do. So, obviously, that'll not be the people currently working or heading ISRO. It'll be obviously be one of us, or like all of us working on it to make it successful. So, my question is, what are the things that are expected of us, or more than expected? What are the things that we should do to make those things a success, and to actually ensure that they are successful? And how do we build upon of what like plan to be after 2050, like maybe after till to 2100 or maybe further, build up a stronger foundation?
Yeah, see, for example, again, I'll give you back the same example what I started with. When the first thing went up, people like Sarabhai and Baba, they visualized what could be the solution for us using this technology. See, today if you talk of what are the technology, new technologies you are talking about, quantum or AI, a whole lot of things you are talking about. Now, if you can visualize using these technology, what solutions you want to provide for the benefit of either the society or humanity, then if you can come up with such things, then definitely that's the way to go. But then that is a real challenge. So here, why there are only one Sarabhai or one Baba, etc., because they were able to do that. It's not that you cannot do. Probably you have within you all the intrinsic capability to do that. But if you energize yourself, become aware of your own capabilities, what you have, maybe you will achieve. You should seriously think about it. I am not joking.
Okay, one last question from there and one from here, and then we conclude. No, he'll be available. So, you know.
So, sir, firstly, thank you so much for the talk. It was really, really insightful, and I'm sorry it's been a lot of questions. But my question to you is more regarding how, like technology is evolving in space. There are new careers like space law and a lot of things that are coming up. How do you think that we as students can, educate ourselves about that technology or make ourselves up to the level of, being the next generation of creating technology?
Very difficult questions. Okay. The only way is by continuously looking at how things are happening, what changes are taking place. That's the only way to know what is happening, isn't it? Is there any other way? Only look out and then be on the lookout for things which are happening elsewhere. And beyond that, the rest of it is within you. That's what again I'll come back to. You are able to see what is happening around, and then how you can make use of it. Even space law, if you take, that means if you want to get into, there is going to be a lot of problems, because in space now it is like who is going to regulate, who is going to control, and then whether somebody will, whatever problems that are going to come. Humanity has always seen that finally it is those with the competence who will dominate, and then if somebody wants to regulate, they should have higher competence level than those who are actually operating. So these are, anyway, fundamentals are not changing, but the way it is being done is changing. So I don't think I have an answer for your question really.
This is Arunan from IAC. Thanks for a comprehensive 60-minute summary and 50 years of ISRO. In the beginning, you said ISRO was among the only space organization for non-military applications. Is this changing?
Yeah, obviously you can see the starting was like that, but as you keep growing, you have such friendly neighbors. Can you afford to not use the knowledge and the skills you have for protecting yourself? That is one part. Second part is, as you keep growing, you have also seen you are recognized for your demonstrated competence. And if you are competent, people will recognize you. So you have seen how things have happened in the nuclear era. So if in space, ability to have humans in space is the new capability requirement, if it is not there with you, will you be among the whatever top? And whether you want to reach that or you want to stay back the way it happened in the past determines whether you should remain non-military or military.
Okay, thank you. We will conclude now, and thank you for a very inspiring talk. And you know, this, I hope, gives you all the message that if you believe something and you put in the work, many things are possible. Okay, and so thank you once again, and we will conclude now.
Yeah.
Thank you. So much.
So with that, we have formally come to the end of day's proceedings of the meeting. So we'll resume our sessions tomorrow at the faculty hall of the main building of the Indian Institute of Science. So we'll now proceed to dinner at the main guest house lawn. Thank you. See you again.